All right, so this is our Unit 4 review, and remember that there are 2 tests that you can do with Unit 4. They both have the same amount of questions, they both have the same kind of questions, they just have different numbers so you can keep practicing the skill. Also, at the end of the questions on the answer page, you're going to see that each one of those questions has the unit lesson that it comes from. And so if you look at your answers and you realize, I got 23 and 24 wrong, you look and see that they are both from Unit 4.9, Solving Equations by Factoring. And so you can just come up to me and say, hey, Emily, I really just need some help still with solving equations by factoring. And I can give you some more practice questions and I can help walk you through it. And so each one of the questions on the practice tests will correspond with one of the lessons that we've done with Unit 4. Just a couple of things to remember. Unit 4 contains the hardest math that we are going to do in this class. So if you're watching this video and all of a sudden things just get really confusing and overwhelming, stop the video. Go back and review some things that you do understand and you just need to reinforce and practice a little bit more. That might be the beginning of the Unit 4 video. It might even be going back to Unit 3 or Unit 2 or even Unit 1, those foundations that we need to make sure are solid before we can understand the stuff in Unit 4. So use it as a tool, but don't be intimidated by it and don't be afraid to say, you know what, I don't think I'm ready for this level yet. Let's go back and review some things that I am ready for. It's just here to help you. So having said that, let's go ahead and get started. So for Unit 4, Test A, numbers 1 and 2 and 3 are all dealing with exponent rules. And so if you weren't here for our exponent rules class or you need to go back and review that, go ahead. That is lesson 1. But we know that when we are multiplying exponents, we can do some shortcuts. A to the third power times B to the second power times A times B to the fifth. Well, the first thing that I would suggest doing if this looks pretty confusing is go ahead and put your variables together. Since this is all multiplication, then we can rearrange our parts without having to do anything extra. So let's put our A's together. A to the third times A. And remember, if it doesn't have an exponent, it always has that invisible 1 there in its place. Times B squared times B to the fifth. And what we know is when we have an exponent with, or a base with an exponent, times that same base, we can keep the base and add our exponents. So that takes care of our A's. With B, we're going to keep the base and add our exponents. So if we were going to clean this up, it would be A to the fourth, B to the seventh. And that's our answer, A to the fourth, B to the seventh. Now for number 2, we have an exponent outside of the parentheses right here. And so in order to get rid of those parentheses, we need to apply that exponent of 2 to everything inside the parentheses. And so that's going to give us 3 squared times x to the third squared, because the whole thing gets the 2 applied to it, times y to the fourth squared. Well, the first one's easy. 3 squared is just 3 times 3. That's 9. X to the third power raised to the second. That's 1 base with 2 exponents. That means we keep our base and we multiply our exponents. So 3 times 2 gets us to an exponent of 6. Y is the same thing. One base with two exponents, y to the 4 times 2, which will be y to the 8th. So our answer is 9x to the 6th, y to the 8th. Number 3 tells us to simplify and reminds us that we don't want any negative exponents. So in order to get rid of a negative exponent, all you have to do is move the base with the negative exponent to the other side of the fraction line. And that very act of flipping it to the other side of the fraction gets rid of the negative sign. So our 4 stays on top because it's not attached to the negative 2. Then we have that b to the 3 on the bottom times b to the 2nd power. So just by moving it down to the bottom, we were able to get rid of that negative sign. So now we just need to clean it up a little bit more. That 4 stays on top. There's nothing I can do with it. But I have a base with an exponent times that same base with another exponent. So I keep the base and I add my exponents, which means it will be 4 over b to the 5th power. Numbers 4 and 5 are combining like terms with polynomials. So we know combining like terms is adding and subtracting things that have coefficients and variables and exponents in them. So we're going to look at this 8x squared, and the other thing that has an x squared is this negative 3x squared. So we would put 8x squared minus 3x squared. We're just going to keep it together. Minus 5x, and the other thing with an x is that positive 2x. So when we are adding or subtracting polynomials, like terms, we keep the variable and the exponent. So that x squared just stays an x squared. We do the math with the coefficients, with those numbers that are attached to the variables. So in this first instance, we're going to do 8 minus 3, which will give us 5x squared. And if you need to, go ahead and mark them out once you've worked with them. Now we have a negative 5x plus 2x. So we're going to keep the x. Negative 5 plus 2, you can do it on your calculator, or you can think about money. I owe someone $5. I pay them $2. Do I still owe them money? Yes. So my answer is going to be a negative number. How much money? I still owe them $3. So negative 5 plus 2 is negative 3. And that's as far as we can go with that because the x squared and the x are not exactly the same. They're not like terms. So we can't do any more subtraction. That's just as simple as we can go. 5x squared minus 3x. So for number 5, now we've got these groupings. Remember, parentheses, if they're not side by side, means that we're creating groups. So we have this group of 4t minus 3 minus this group of negative 3t plus 6. Well, when you have a minus sign in front of a parentheses, you need to do a little bit of a fancy trick to get rid of the second parentheses. So we're going to go all the way back to the idea of keep, change, change. And remember that keep is you just keep the first term exactly how it is. So that would be 4t minus 3. Your first change is always that subtraction becomes a plus sign. So this guy is now going to be a plus. But in order to do that, we have to change the signs of everything that comes after that subtraction. So we have to change this sign and that sign. So instead of a minus 3t, it's going to be a plus 3t, or we could just say 3t. And instead of a plus 6, now it's going to be a minus 6. And now we're just back to combining like terms. So if you need to group them together, go ahead. 4t plus 3t minus 3 minus 6. So 4t plus 3t is going to give us 7t minus 3 minus 6. Think about it as I owe someone $3 and then I borrow $6 more off of them. Do I still owe them money? Yes. So my answer has a negative sign in front of it. How much money? I owe them $9. Number 6 is still working with polynomials, but we are multiplying the polynomials. And we see that we've got a binomial in front, something with 2 terms, times another binomial, something else with 2 terms. So when we have it set up like this, where we have one math problem inside parentheses times another math problem inside parentheses, we need to use FOIL. So FOIL says we're going to multiply the first terms, then we're going to multiply the outside terms, then the inside terms, and then the last terms. Then we're going to combine any like terms that we can, and what's left is our answer. So the first terms will be 3j times j, which is going to get us to 3j squared. The outside terms will be 3j times 3, which gets us to 9j. The inside terms will be negative 2 times j, which will get us to negative 2j. And the last term will be negative 2 times 3, which gets us to negative 6. So we've got all 4 of those terms. We're going to look and see, are there any that are like terms, any that we can combine? And yeah, we can combine these guys. 9j minus 2j would get us to 7j. So our answer is going to be 3j squared plus 7j minus 6. Number 7 is about dividing polynomials. And remember that we can split a polynomial up as long as we make sure it stays under the same denominator all the way through. So we can take this guy and we can do 4r to the 4th divided by 2r plus 6r squared divided by 2r. So I can split it at this plus sign as long as I make sure that both parts of the fraction are still having the same denominator, that 2r. So now I can do some simplifying. I know that 4 divided by 2 is just 2. And r to the 4th divided by r, remember we have that 1 right there, that would be r to the 3rd. Plus 6 divided by 2 would give me 3. And r squared divided by r would just give me an r. So this goes back to our exponent rules. If we have the same base with different exponents and they're being divided, we can keep the base and subtract the exponents. So that's how we get our r to the 3rd. Or if I have an r squared divided by r, that would be r to the 2 minus 1. Because remember, we've always got that invisible 1 as an exponent if there's nothing written there. So that's how we're getting to our r to the 3rd and our r. To get our coefficients, we're just doing 4 divided by 2 and 6 divided by 2. So that leaves us with 2r to the third plus 3r. Number 8, solve for n. This is what we call a multi-step equation. That was the lesson where we had those 5 different steps to work through. And the first step is always getting rid of the parentheses. So I'm just going to go ahead and rewrite it over here. 4 times the quantity of n minus 4 minus 2n equals negative 22. To get rid of the parentheses here, it's a multiplication problem, but I only have one term on the outside of the parentheses. So in this case, I can use distributive property. That just means I take that 4 and I multiply it by everything inside the parentheses, and that's how I can get rid of that parentheses. So 4 times n will give me a 4n. Minus 4 times 4 gives me a 16. Then this minus 2n just comes straight down. And the minus 22 just comes straight down. Now we can do some combining like terms. 4n minus 2n. So we keep the n and we do the math with the numbers. 4 minus 2 gives me 2. Then that minus 16 just comes straight down. And now we're just back to a 2-step equation. So we're going to get rid of the constant first. We're going to add 16 to both sides. And that's going to give me 2n equals negative 6. Negative 22 plus 16. I owe someone $22. I pay them $16. I still owe them $6. Now we have 2 times n, and we're trying to get rid of that 2. So we're going to have to do the opposite of multiply, which is divide. So when we divide by 2, that cancels out. When we divide by 2 right there, we're going to get n equals negative 3, because a negative divided by a positive gives us a negative answer. For number 9, it's the same idea as number 8, but I noticed that I have a variable, that z, on both sides of the equation. So that means that at some point, I'm going to have to get rid of a term that has z in it on one side. I'm going to have to get all of my z's over to one side of the equal sign. But we're not there yet, so let's just get rid of our parentheses first. So again, I'm going to write it up here so that we've got some room to work. So I'm going to use distributive property. 6 times z is just 6z. Plus 6 times 3 is 18. That minus 8 just comes straight down. And the 3z plus 22 just comes straight down. So now I'm looking at it, and is there anything I can do to simplify stuff? Well, yeah, I can do that 18 minus 8. That would give me a 10. So I've got 6z plus 10 equals 3z plus 22. So here's the point where I need to cancel out one of those z terms, because I've got z's on both sides of the equal sign. I like to cancel out the smaller of the 2 terms. So I'm going to work on this 3z. And there's a few ways that you can think about it. But remember, if something doesn't have a sign in front of it, it's always a positive number. So if I'm wanting to get rid of a positive 3z and I want to get rid of the whole thing, I'm going to subtract it. 3z minus 3z is going to cancel it out. But if I subtract 3z on one side, I have to subtract 3z on the other. So 6z minus 3z gives me 3z. That plus 10 just comes straight down, and that 22 just comes straight down. And now I'm back to a 2-step equation. So we're going to be solving it by subtracting the 10 to make it go away on the left and subtracting the 10 on the right to keep it even, make sure that it's equal. So we're getting 3z equals 12. Then I want to get rid of that 3, so I'm going to divide both sides by 3, and that gives me z equals 4. Number 10 wants to know, is the graph at the right a function or not? Remember, if something is a function, that means that our x values, the x part of each point, does not repeat. So if they're looking for it on a graph, all we have to do is take our pencil and draw a straight line down any part of the function. A straight line here, it's got to be vertical, or a straight line here, or a straight line here. And every time I draw a straight line, I'm only hitting the graph at one point. I'm not hitting the graph at more than one point. And so is it a function? Yes, it is a function. Number 11 wants us to solve the function. So remember, if they give us f of x equals x squared minus 2x plus 6, and they use the phrase find, and they have that same letter and parentheses combo, but now instead of an x on the inside, we're going to have a number. That means that anywhere we see that x, we're going to put that number. So instead of x squared, we want 4 squared. And instead of minus 2 times x, we want minus 2 times 4. And then that plus 6 just comes on down. So if we do this on our calculator, we're going to do the 4, and then the x squared key, and then minus 2 times 4 plus 6, enter. And that's going to give us 14. For number 12, they want us to find the inverse function, which may have that little -1 as an exponent. But all it means is we just go through our steps. And for the first one, instead of writing f of x equals 5x plus 2, we use a y. So y equals 5x plus 2. Then because they said inverse function, we're going to switch the places of our x and our y. So it won't be y equals now, it will be x equals 5y plus 2. And now we just need to take this equation and solve it for y. We want y all by itself. So we're going to subtract 2 to get rid of that, and subtract 2 over here. Now I can't actually subtract 2 from x. They're not like terms. I can't combine them. So it just becomes x minus 2 equals 5y. Now I want to get rid of that 5, so I'm going to divide by 5 on both sides. And again, I can't simplify that x minus 2 over 5 anymore, so that just becomes my answer. 13, they give us an equation, y equals 3x plus 4, and they want the slope. Remember, the slope is the number that is attached to x. So if we're thinking about it as slope-intercept form, that slope is whatever number is right here. And in this case, that's a 3. So our slope is 3. And that's it. Now for 14, graphing the linear equation, remember we want to start with the b. We want to start with that y-intercept. So in this case, our b is a -1. That means that our line will go through the y-axis at -1. So we want to go ahead and put our point there. Then we use our slope as a roadmap. And slope is always rise over run. How far up and down over how far left and right. So because these are both positive, we are going up 2 spaces from the -1, and then we're going to go to the right 3 spaces. So let's go up 2, and then to the right 1, 2, 3. And that will be our next point, and we just have to draw our line connecting those two. For 15, they want to know, do these two equations below represent perpendicular lines, parallel lines, or neither? Remember, if things are parallel, they will have the same slope. If they are perpendicular, they will have the opposite reciprocal. And if it's neither one of those, then it's just neither. So let's look at the slopes for both of these equations. In the first equation, our slope is 4. In the second equation, our slope is -4. They are not the same slope, so they cannot be parallel lines. For this to be perpendicular lines, we would have to have one slope, 4. Let's turn it into a fraction, 4 over 1. We're going to flip it, so that would be 1 over 4. And then we are going to flip the sign. 4 over 1 is positive, so our new slope would be negative, -1/4. Well, -4 is not the same thing as -1/4, so it's not perpendicular either. So the answer to 15 is that these two lines are neither parallel nor perpendicular. For number 16, they want us to graph the linear inequality. So it's not an equation anymore, it's an inequality. This one has y is less than -2x plus 2. But it starts the same way as graphing a linear equation. We start with our b. In this case, our b is 2, and we find our slope. Our slope is -2, and we want to turn that into a fraction, so we're doing -2 over 1. B is my point, so I'm going to put a point at 2 on the y-axis. Then I'm going to go down 2 spaces and to the right 1 space. So those are my 2 points. But with an inequality, there are 2 characteristics. One of them is the type of line we are using. Are we going to use a solid line, or are we going to use a dotted line? Because this is y is less than, it's going to be a dotted line. If it had an or equal to, then it would be a solid line. But because it's just the less than, it is a dotted line. Now we need to figure out shading. Are we shading above or are we shading below? Well, that comes into, is y less than or is y greater than? If y is less than, we're going to shade below the line. If y is greater than, we're going to shade above the line. And in this situation, y is less than, so we are going to shade below. 17 is one of my favorite questions on the whole test because it looks so complicated. But the solution, or the solution to the system of equations, if they give it to you as a graph, the answer is simply, where do those 2 lines cross? Where do they intersect? And for this question, they are crossing right here, and the point is 1, 3. And so the solution to the system of equation is the point 1, 3. Or you could also say it as x equals 1 and y equals 3. They're both right answers. For 18 and 19, solving the system of equations, This review doesn't give us multiple choice, so I'm going to show you how to do it to get to the right answer, whether you have multiple choice or not. But remember, on the exam, you will have multiple choice options, so you can always just substitute in the values and see which ones actually give you true statements. But for now, we're going to solve 18 by elimination. And remember, elimination is where we are creating opposites. And the reason I'm using elimination is that right now we already have opposites. We have a positive 2x and a negative 2x. So when I combine like terms up and down, think of it like I'm adding all of these, the top line and the bottom line together, these two will automatically cancel out. And for my y, remember, if it doesn't have a number in front of it, we can always put that invisible 1 in there. So 1y plus 3y would give us 4y. The equal sign just comes straight down. And 2 minus 10 would give us negative 8. And now we're just back to a one-step equation. If I want to get rid of this 4, the 4 and the y are being multiplied, so I need to divide by 4, and that will cancel it out. And I'll divide by 4 to keep it equal, and I get y equals negative 2. So the first half of my answer is negative 2. Now I'm going to take that negative 2 and I'm going to substitute it into one of the equations. So I have y equals 2x plus 2. And I'm going to put negative 2 equals 2x plus 2. And now I'm going to be solving for that x. I'm going to get rid of my constant first. So I'm going to minus 2 to make that guy go away, minus 2 to keep it even. So that's a negative 4 equals 2x. Now I'm going to divide by 2 on both sides, and I get x equals negative 2. So in this situation, both x and y are negative 2's. So for number 19, we're still going to use elimination. So I'm still going to try and create opposites. But in this situation, I have got to do some multiplying to make opposites happen. So one way to do that is to look at your pairs and see, is there anything that I could multiply them by that would get them to become opposites. So I'm going to try these y's. I want this top one to be a positive 6y, and I want the bottom one to be a negative 6y, so that they will cancel each other out. Well, to get 2y to become 6y, I have to multiply it by 3. 3 times 2y would get me to 6y. But that means I'm going to have to multiply the 3 by all of those parts. Let me do a dot there instead of an x so we don't get confused. So 3 times 2y. 3 times 5x gets me 15x. 3 times 2 gives me a 6. So now looking at that 3y down here, to get that to become a negative 6y, I would have had to multiply it by negative 2. But that means I have to multiply everything by negative 2. So negative 2 times 2x would be negative 4x. Negative 2 times negative 3 would be a positive 6. So now I'm going to do some combining. 6y minus 6y, they cancel out. It just gives me a 0. 15x minus 4x would be 11x. Minus 6 plus 6 also gives me a 0. So these guys canceled out and these guys canceled out. Well, if 11 times x equals 0, we know that x has to equal 0 because anything times 0 is the only thing that gets us back to 0. So my first part of the answer is 0. Now, I am going to take one of my equations, 2y equals 5x minus 2, and I am going to put the 0 in instead of the x. So that's going to give me 2y equals negative 2. Now it's just a one-step equation. I'm going to divide by 2 on both sides, and I'm going to get y equals negative 1. 18 and 19 are pretty tricky, especially if they're not giving you answers to choose from. But again, remember on the test, you will have those multiple choice options. So you can just put in the x's and the y's and see which one actually gives you the right answer. If you're confused about it, I can show you how to do it. For 20, 21, and 22, when they're talking about factoring completely, they want you to break it down to its individual components. So break it down as much as you possibly can. And one way to do that is to go ahead and see, are there any factors that both terms have in common? So if we look at this 6x squared plus 9x, I could break that down into 3 times 2 times x plus 3 times 3 times x. And if I do it that way, I can see that both terms have a 3 in common and they have an x in common. So what I'm going to do is I'm going to pull that 3 and that x to the outside. And then I'm going to create parentheses, and whatever is left, 2x plus 3, is what goes into the parentheses. And so if we factor out this binomial, what we get is 3x times the quantity of 2x plus 3. That's as broken down into its individual parts as we possibly can do. But sometimes we don't have a common factor in all of our terms. Like if we look at 21, there's nothing that I can take out of all 3 of those terms. They don't have anything in common. And so at that point, I need to create 2 binomial expressions. And sometimes we call this reverse FOIL. When you're doing reverse FOIL, the first step is you take the first term and you split it apart. So x squared is literally x times x. So we'll have an x here and an x here. The next thing you do is you look at your last term, negative 15, and you want to break it down into all possible factors. So that could be a negative 1 and a positive 15. It could be a 1 and a negative 15. It could be a negative 3 and a positive 5. Or it could be a positive 3 and a negative 5. If I multiply those pairs each time, the pair will give me negative 15. So those are my possibilities. Those could be my second numbers in each one of the binomials. How do I know which one? I look at this middle one, plus 2. And I'm looking for, if I take that pair and I add it together, which one will give me an answer of positive 2? Well, that would be negative 3 plus 5. So I would have x minus 3 here and x plus 5 here. So my answer would be x minus 3 times x plus 5. Now with 22, we're getting even a little bit more complicated. We're actually going to combine the things we did with 20 and 21. So we're going to start by looking for a greatest common factor. And if I take this 20 and instead I talk about it as 5 times 4, then that shows me that they both have a 5 in common. So that's where I'm going to start. 5 times the quantity of x squared minus 4. And if you remember, now we're looking at one of our shortcuts, the difference of perfect squares. And as soon as we have a subtraction problem where both sides are perfect squares, we can split that up one more time. So that 5 just stays there. That x squared becomes an x and an x. The square root of 4 is 2. So we're going to have a plus 2 and a minus 2. Remember, that's our shortcut, the difference of perfect squares. So ask me about it if it's confusing, but our final answer becomes 5 times the quantity of x plus 2 times the quantity of x minus 2. So 20 through 22 have all been just about factoring. 23 and 24 finally give us an equal sign and they want us to solve. So what we are going to do is we are going to look at this already factored binomials and we're going to say x minus 2 times x plus 3 equals 0. Well, then all we have to do is use that 0 guarantee. If these two things multiplied together equals 0, then one of them on its own also has to equal 0. So we can split it up and we can say x minus 2 equals 0 and x plus 3 equals 0. Then we just solve for x. X equals 2 or x equals negative 3. So my options are x equals 2 or negative 3. Another way that you might see this written is the number brackets, not parentheses, 2 comma negative 3, and then the bracket, because remember the brackets just mean number sets. 24 is similar in the fact that it wants us to solve for x, but it hasn't factored it out for us yet, so we need to do the factoring. So we're going to go ahead and do our 2 parentheses. There's no common factors between all 3 terms, so we're going to go straight into reverse FOIL. That x squared gets broken up into x, and then we look at our negative 20. And the factors of negative 20 would be negative 1 times 20, 1 times negative 20, negative 2 times 10, 2 times negative 10. Oh, I'm going to run out of space. Negative 4 times 5, or we'll go up here, 5 times negative 4. So all of those pairs, if I multiplied them together, would give me negative 20 as an answer. Which pair is dependent on this guy? And remember, if you don't have a number attached to your letter, you can always write in that invisible 1. So which one of my pairs, if I added them together, would give me a difference of 1? Well, 5 plus negative 4 would give me that 1. So it will be x plus 5, x minus 4. Then we're going to do our 0 guarantee. X plus 5 equals 0 or x minus 4 equals 0. That means x would be negative 5 or x would be positive 4. So I can write it negative 5 or 4, or I can write it as a number set. 25 and 26 are dealing with the quadratic formula. 25 is an easy one. We're just identifying parts. And remember that our format is ax squared plus bx plus c equals 0. So if they want us to identify the a, b, and c, the first thing we have to do is make sure that our equation equals 0. It does. Negative 2x squared plus 5x plus 3 equals 0. So we're good. The next thing is remembering that the a is the coefficient that's attached to x squared. So in this case, our a is a negative 2. The b is what's attached to x. So in this case, our b is 5. And the c is what's at the end, that constant. So our c is 3. So 25 is just identifying the parts. We're not even using it yet. 26 is where we would need to use it. So if they want us to solve using the quadratic formula, you're going to first make sure that it equals 0. It does. We're good. Then we are going to identify our parts. A equals 2, B equals 3, and C equals 1. Then we're going to use the quadratic formula to solve for x. So x equals negative b. My b is a 3, so that's going to be negative 3 plus or minus the square root of b squared, so that's going to be 3 squared, minus 4 times a, that would be our 2, times c, that would be our 1, all over 2 times a, which would be 2 times 2. Grab your calculators and go ahead and do the square root of 3 squared minus 4 times 2 times 1. And you're going to come up with the square root of 1, which is just 1, right? So at this point, we are going to divide, and we're going to say x equals negative 3 plus 1 divided by 4, and x equals negative 3 minus 1 divided by 4. Negative 3 plus 1 would be a negative 2. Negative 2 divided by 4 would be negative 1 half. Negative 3 minus 1 would be negative 4. Negative 4 divided by 4 would be negative 1. So my two possibilities for x are the numbers negative 1 half and negative 1. Again, if you remember me talking about quadratic equations and quadratic formulas, these are hard questions on the test. So there is nothing wrong with you making your best guess and then marking it for review and finishing the test. And if you have time, coming back and trying to actually work it out. Because if you're not used to doing quadratic formula, it can take you 5, 7, even 10 minutes to do one problem, and you don't have that kind of time on the test. So make your best guess, flag it to come back to it, then after you've finished everything and you've checked everything, come back to that if you still have time at the end. We are skipping 27, 28, and 29 because I've never seen those kinds of questions on any of the practice tests. So again, if you ever take the test and you come back and you say, Emily, we really need to study those, I will absolutely bring them in. But for right now, I just want you to cross them off. Don't worry about them. And let's go ahead and move on to question 30. So question 30 wants us to simplify. That means to get something down into its lowest terms. So we're going to start by factoring. 3x plus 9, they both have a 3 in common. If I would take this 9 and do 3 times 3, then I could pull one of those 3's out. and that would give me x plus 3 inside the parentheses. Same thing here, 3 times 1, I pull these 3's out, and I get x minus 1. Now I can cancel out those 3's, and my answer is simply x plus 3 divided by x minus 1. For 31, again, we're going to start by factoring anything we can factor. So this 3x plus 6, we're going to talk about it as being 3 times x plus 2. And this 15, we're going to talk about it as 3 times 5. So that means those 3's cancel out. That 5 on top, there's not a whole lot I can do with it. But this x squared minus 4 is the difference of perfect squares. So that would be x plus 2 times x minus 2. And remember, when you have multiplication between two fractions, not only can you reduce top and bottom, you also can reduce diagonally. So we've got that x plus 2 on the upper left-hand side and that x plus 2 on the bottom right-hand side, and those guys are going to cancel each other out. So we're going to have a 5 on top. Oh, no, we're not, because that 5 and that 5 will cancel out. So we're going to have a 1 on top and an x minus 2 on the bottom. 32 and 33 are how to solve equations that have radicals in them. Those radicals are these root signs right here. And remember, if there's no little number out here, then it's just the square root of something. And to undo a root, you need to do an exponent. So to cancel out the root sign, you're going to do an exponent. But before you can cancel out the root, you have to make sure it is all by itself on one side of the equal sign. Well, yeah, even though we have a math problem underneath it, it is all underneath that square root. So we're ready to cancel it out. We're ready to get rid of it. If this is a square root, to get rid of it, I am going to square everything. But if I square on one side, I have to square on the other side as well. So that's going to get me to 5w plus 1 equals 16, because 4 squared is 4 times 4. Now we're just down to a two-step equation. I'm going to subtract 1 from both sides, cancel out there, 5w equals 15. Then I'm going to divide by 5, and w equals 3. So that's 32. Now 33, I do have a square root, but I still have something that's on the same side of the equal sign, but is not underneath the square root. So I need to get rid of that guy first. So I'm going to add 2 to cancel him out, and I'm going to add 2 over here to keep it equal. So now I'm at the square root of 2x plus 8 equals 2. And I'm ready to square so that I can get rid of that square root sign. So 2x plus 8 equals 4. I'm going to subtract 8 from both sides, and I'm running out of room, so I'm going to move it over to the side. That gets me 2x equals negative 4. I'm going to divide by 2, and that gives me x equals negative 2. So if we have a root, we have to do the power to cancel it out. Exponents and roots are opposites. That's how they cancel each other out. And that's the end of Test A for Unit 4. So remember, here are all of our answers that we just went through, and they have the unit lesson attached to them, so that if you missed a bunch of them, let's say that you missed 4, 5, 6, and 7, you could just come up to me and say, Emily, I really need help with that unit 4.2. I'm not getting that at all. So take a second, look over the ones you got right, look over the ones you missed, and then look and see if those missed ones are coming from similar units so that we can go over those concepts again.